Hello, welcome to Advent of Code, day 12. Yesterday we had a bit of a hiccup with being unable to solve part 2. Well, we did solve it, but it's too slow, so yeah. We'll have to try again, maybe today, but I'm not sure because today's challenge looks a bit complex. I'm not really sure how to solve it. I have an idea, but we'll see. So basically, day 12, garden groups. An apt name, because what we have to do is find the groups, like those A's form a group, those B's form a group, and so on. And we have to basically multiply the sizes of all groups with the fencing around the group. So each group has like how do you say, a border, and you have to count how big this border is, and also how big the area is as well. So yeah, that's basically it. And then you do some calculation. I'm really sure I haven't got that far yet. So basically you do the price of a fence required for region is found by multiplying that region's area by its perimeter. The total price is found by summing everything up. All right, so we have an idea on how to do this. Uh, so my idea is basically it's pretty simple. So you find this with, I guess, recursion or something. You find the sizes of each region. You save it into a map, I guess. Maybe, yeah, a map is looks fine, and that's for the area. Now for the perimeter, so the border, I guess you just go and count, like you just do a for loop. Basically, you have a map and you go with a for loop through everything. And for example, you take this A and you increase the count for every neighbor that is not the same letter, basically. So for this A, you've got 3. For this A, you've got 2, 2, and 3, which is like 6 and 4, it's 10. So, where is it? Where is it? Where is it? Up, 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 up. I'm sure I saw a 10 somewhere here. Ah, type A and C are of size 10. So yeah, A is 10. Let's try C. 1, 2, 3, 4, 5, 6, 7, 8. No, that's not working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it is. I hope it works. I'm not really sure. Well, I guess let's try it. So as usual, I've already done the input parsing, so we can go straight into coding. So first thing, let's do the perimeter because it seems simpler. Uh, calculate perimeter. We're gonna need the grid, which I just put as a string, an array of string, and that's basically it, I think. So what we're gonna need is a map. So we're gonna name it perimeter map. It's gonna be a map. Uh, so an element of string is a rune, I think. So a rune, I guess, and we're just gonna count. So an int. Okay. Now I don't know if I have to initialize the map. I hope not. But basically, we just go through everything. So we have the row of range grid, and then another for which we have the element of range row. Okay, and now we just check everything basically. So first let's initialize speed to 0, and now if we're gonna need the I j, of course. So if I minus 1 is bigger than 0 and grid of I minus 1 and j does not equal is bigger than 4, we really need to do something else here. So if I minus 1 is less than 0, or or it's bigger. So if it's less than 0, it will match. But if it's more than 0, it will not match, so we don't need to check this, probably. And if it's not the same as the element, we can increase the sum, or p in this case. Okay. We have a problem here. Mismatch type byte and rune. Why is it mismatched? It's a rune. Okay. We're gonna do it the old-fashioned way then. So we'll just do we'll just do it like that. Grid of I and j element. Alright. Alright, and now we do the same. We can just probably copy this. Paste. We do the same with j minus 1. And then we have to check if I plus 1 is more than or equal to what is this, len of grid, or what, grid of I plus 1 and j does not equal the current element. We increase the p, and we can copy this as well. Paste this, have the j, and have to put 0 here, and j plus 1. All right, seems fine. Now we have to check if the element exists. If perimeter map, oh, no, we have to, if perimeter map, let's do M or OK. Perimeter map of, what is this, L? This is a byte now, right? Or what is this? It's a byte. Okay, let's do a byte, I guess. L. So if OK, then what do? We take the perimeter map of L and set it to M plus P, right? Or else perimeter map of L is just gonna be P. Okay, so let's try. So we call calculate perimeter of the grid, And then we can probably just print out the perimeter map. Let's see what happens. Assignment to entry in nil maps. I have to figure out how to initialize the map. Okay, so let's do perimeter map equals, I guess, map of byte. Come on, Visual Code, you did it. Byte. Oh my god. Map byte and something like that. All right. Okay, and we have some numbers here, but let's rather do in test 2. 10, 8, 10, 4, 8. Okay. 10, 8, 4. Yeah, seems all right. Let's do this one now. 32, 18, 18, 30. Okay. 32. So 40, 32. Oh, they're not in order, probably. Not that they're not in order, they're not correct, actually. So we have A. Oh, that's the price. I'm looking at the wrong thing. Pretty sure 67, isn't that A probably, right? There's no A here. Yeah, great. What's the ASCII table? 60. 67 is C, all right. Why is C the first? So C is 1428. That doesn't seem right. So let's see. Let's try a smaller one. So a region of, oh, they can be, all right, they don't have to be together. Okay. That complicates things a bit. Okay, so we have to first find them and then, okay, I got it. Okay. So the algorithm is correct, but we need to do a few modifications here. But first we have to find regions. I'll find groups, I guess. All right. Probably should move this here. And I'm going to rewrite this into an integer map, actually, or an integer grid. So let's call it one new grid. It's going to be an array of integers, I guess. All right, and when I initialize the new grid, no, we need to, how do you initialize this? I guess you just say, we need a 2D array. I guess you can just say a length of the grid. and another line of the grid of 0 and something like that. Nope. Yeah. One and one. Oh, I put the wrong thing here. Oh, what? So do I need to put this as well? I mean, how do I? Hmm. I need to the array with fixed size. Okay, I guess. I mean, but I can do this now, right? New grid 2 equals new grid. No, this is weird. Hmm. We can just return the new grid, I guess. I pretty like. Right, so we call make, and we do end with the size of line grid. What's the problem? Yeah, for in range grid, I guess. M of I equals make another integer array with the size of len of grid of 0. And we have a problem again. Oh, shit. Oh, new grid. Okay. Initialize the new array, and yeah, now we go. And set the, so we start with ID 1, I guess. And by finding it, so we have the grid string and the new grid. And we have the I and J position and the byte we're looking for. So the group, I guess. Is it gonna return anything? Probably not. Ingredient, or rather on this side. Okay. So if in this position, so in new grid of I and J equals or does not equal 0, that means we've already been here. We can just return. Okay. So if we have not yet been here, if the grid of I and J equals the symbol we're looking for, we mark it equals, oh, and we also need the ID, yeah, equals ID, and then we check all the other directions, which is not optimal, but maybe. So we go grid, new grid, I +1, J, group, and ID. And we do this 4 times actually. -1, +1, +1. Okay, and we also have to do the checks. So if I is less than 0 or J is less than 0 or I is more than or equal to length of grid, or J is more than or equal to length of grid of 0, we also return. Okay, I think that should work, I guess. And then we just go through the grid. And grid or J in or J equals range of grid of J, or I, sorry. Okay. And if the new grid of I and J equals 0, we do the find grid, new grid, we start at position ij. We are looking for the grid of I and J, and the ID is ID. And at the end of this, we increase the ID. Okay, and we also return the new grid. Okay, so let's first find groups. We put in the grid, we get the new grid back. Okay, and then we just print the new grid and see what we get. New grid, okay. Okay, we're not in a loop, which is nice. Now let's compare. The problem were the C's, right? So the C's are marked with a 3. Right, that seems to be working. Now, so there's like a lone C in 1, 2, 3, 4, 5 in the fifth row, and 1, 2, 3, 4, 5, 6, 7, 8 column. Fifth row and 8 columns. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, they don't have the same ID, which is perfect. Now we can do this thing on an integer map. And it's basically the same. The only difference is we're working with new grid. No, we can leave grid here. The only thing we have to change is this. And I think it should work now. Oh yeah, I should remember. Yeah, all right. Let's do this first. So let's see. 18, 8, is this 18, 8, 20? Right, that's still not entirely correct for some reason. Hmm. So R's are correct. I's are also correct. Are they? 1, 2, 3, 4, 8, 11, 12. No. What? 8? Oh, yeah, yeah, that's correct. 18. So I is 8. And now we have C's. It's so we have C's, which is 12, but somehow the example has 28 here. A region of sea plants with prawns. Maybe I'm missing something. The above contains 5 regions. I'm not really sure what the problem is here. We have 3 and 3 threes, and we have 2 3. Oh, something's wrong here. This should be a 3, ideally. Maybe I missed some indexes. So if I is less than, if j is less than, if I is, if j, no, that seems fine. If new grid of I and j is not does not equal 0, return. Oh, that seems fine. if grid of ij equals group, right? Oh, of course, of course. I hope this is better now. 18, 8, 28, 18, 20, 24, 18, 22, 12, and 8. All right, this is great. Now the only thing I need is to count the size, which I should probably do here. And we're gonna return an integer, return 0, return 0, and return 1. Like that. Sum plus equals this, and we're gonna put that here. And have 1 plus sum. And I need to put sum outside, of course. I'll do it like that, actually. Okay, and we don't need this, I hope. Okay, now area size is this. So now where do we put area size? Do we do a map or do we do an array? We could probably get away with an array. We're gonna do it like that. And we're gonna area sizes in area sizes is going to be an integer array, and I think a band actually initializes it. Area sizes equals band, and we're going to return area sizes as well. Okay, new grid, area sizes. Okay, what do we do now? Well, we basically go through the perimeter map, and yeah, calculate price part 1. How do we look through a map? Go iterating over all keys of a map. Oh, you just use a range, which is convenient. Range of perimeter map. All right. Now we have to calculate the price. So price, set the price to 0, and price is going to be plus equal to what? The value, which is the perimeter size, and the area size of what? K minus 1. And this should give us our final price. Let's see. Okay. Problem? Let's probably check this. We haven't checked the area sizes. Maybe something is wrong here. 24. Yeah, that's way too much. All right. But why? Why is it too much? Oh, we only count, yeah, if it's the same. We don't count if it's not the same. And we return sum, or else we return 0. Yeah. Yeah, now we got the right result. And I think we can go to the big input. I'm fairly certain this should work. And yeah, so this is a bit buggy right now, but yeah, here we go. Let's see part 2. Fortunately, they are trying to order so much fans that they qualify for a bulk discount. Under the bulk, instead of using the parameter to calculate the price, you need to use the number of sites each region has. Each straight section of fans counts as a site, regardless of how long it is. Okay, that's a bit too complicated. The region containing 11 points has 4 sites. As does each of the regions containing plants of type B, D, and E. However, the more complex region containing plant size has 8 sites. Right, I get it. I don't have the faintest idea how to solve this, but let's try. I'm gonna have to leave in about 20 minutes to half an hour, so let's give it a shot, I guess. So if we're on a straight line, we only count as 1. Yeah, maybe we can do that actually. But no, when we... A wild idea. Not sure how good it is, but like we can do that. Yeah, we have a problem with this. Yeah. No, I don't actually have a problem. So we just kind of do a depth first search, and we start here, and then we know that the A is below us. So we just go to the right until we can't anymore, and that counts as 1. Until we have to make a turn, everything counts as 1. So then we figure out, do we go right, down? Oh, we have to do 2 moves then actually. That's tricky. Yeah, I think I remember from some old Advent of Code, you have to do the corners. You got like 8 possibilities. Sure, that's the correct solution, but I think it might work. So DC is a bit more complicated. So let's say we start. So this is the first C we find. Let's start one up. So here is 1, and then we see that there's no C below here, right? And then we start. So then we get here, and we see there's no C here. Okay, and then we change direction. When we change direction, we do a +1 actually, and then we go down. We get here, and then we go down again. We can because there's a C here, so we go back and try to change direction. We change direction to, well, we can't go up because we came from up, so we go either left or right because we can only change 90 degrees, right? So we can't go to the left because there's a C, so we go to the right. We go to the right, and we can't go to the right, we have to change direction again, but that counts as one as well. And so each changing of direction counts as one. So basically, based on how many corners the shape has, that's how many. Yeah. That's probably the solution. So four sides. So with 1, 2, 3, 4 corners. C has 1, 2, 3, 4, 5, 6, 7, 8, 8, 8 sides. All right. B has 1, 2, 3, 4. 1, 2, 3, 4. Maybe that's the correct solution. All right, so E has 1, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's basically it. So you have to count the corners. So how many turns do you have to do? How many turns do you have to do? So you always need to have empty space somewhere. So here's an empty space. Yeah. So So we start here and just try going right, and we go right until we don't fall down. You know, we have to go around. So we go here and we turn and we turn. And we turn here and we get down here and we have to turn around again. So we go down, we could go right or left, we go to the left, so we turn here. And then we are here, we go here. We are checking for the up. Oh shit, that's kind of iffy. Maybe there's a better way to do this. So this counts as 4. No, we can't do that. Oh, but you have to do this as well. Yeah. So I think in some of the old puzzles there was a clever way to just do a plot fill here and a plot fill outside and then just kind of subtract how many fields there were, but yeah. Maybe if you check for each, like you go here and you check if it has two empty spaces, it's a corner, right? This does not have two adjacent spaces. This one has, this one has, this one. All right, we could do it like that. And then this one does have no, this one doesn't. So it either has two empty adjacent spaces, or alternatively it has, so this as well, or alternatively it has so here's one corner up here. No. No, because they all here. But if it's like here, 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 and here is the not correct one, it's a corner here, right? And if we go here, these are the same, but this is a corner. And if we go here, there are two blank spaces. If we go here, are the same but corner. If we go here, the same but corner. If we go here, that's not a corner, that's the corner. Okay, maybe that's the solution. So let's try it here. So two empty, two empty, two empty here as well. Yeah, that's correct. Two empty here as well. And yeah, now we go here, the same ones and another one. I hope this is it. I'm not really sure, but I hope this is it. So let's do fun. I'm gonna have to stop recording. I mean, I will record, but I'm gonna turn off the microphone in a minute or two. But yeah, the plan is to try this, and if it doesn't work, I'm probably gonna end it for today. But I'm pretty like 70% sure it should work, or 60% sure. I'm not sure, but we'll see. So yeah, that's probably it for today. When it comes to talking. So yeah, let's do calculate bulk perimeter. And yeah, we're gonna reset. Do we have a reset? No. We're gonna reset the perimeter map, and we basically just do the same thing as here, kind of. With one exception. So what do we have to check again? All right. So let's do the outer corner first. Outer corners. All right. If grid I j, so let's say -1 and j does not equal element, and grid of I and j plus 1 does not equal element. That means we are at the corner, right? Okay. Then we check additionally, we can probably just copy paste this. Oopsie. Copy paste this 3 times. Paste, paste, and paste. And then we check the next corner, j plus 1 and I plus 1. Okay, and then we check the next corner, which is I plus 1, j and I and j minus 1, right? And then we have j, oops, j minus 1 and I minus 1 as well. Okay, those are the outer corners, and then we do the inner corners. So for the inner corners, what do we have to do? For the inner corners, we said the adjacent two elements have to be the same and the diagonal one has to be different. Okay. So it's basically the same as this, kind of, with the exception of it has to be equal. And then, additionally, grid of the diagonal one has to be different. J plus 1 should not be the element. And we can probably copy paste that as well. Paste. Paste. And we have j plus 1 and I plus 1. So let's put plus 1 here. And we have j minus 1 and I plus 1. And j minus 1 and I minus 1. And that should be it actually. Only thing to do, we have to do the index checking. So I minus 1 is bigger than 0 and j plus 1 is less than length of grid of just do it like that, and equals length of grid m equals length of grid of 0. So j plus 1 is equal less than m. Okay. For this one, we have to make sure I plus 1 is less than n and j plus 1 less than m. Okay. Plus 1 less than n and j minus 1 1 equal here. Almost forgot. Okay, now I have to go. I hope it works. See ya tomorrow.